So we continue on the same subject, meat quality, and to discuss a little bit about what can be the approaches. For example, to answer the last question about improving pH or glycolytic potential using feeding system approaches. So I'm sure you have seen this figure before. It's kind of old now, but it's decreasing. It's showing the evolution of meat consumption per capita against the net income. And what we can observe is that the more we get money, the more we will shift our habit, our consumption habit, to eat more meat. So the meat consumption is globally and worldwide increasing. And when we look a little bit better about pig meat consumption and poultry meat consumption, so it was your question about pig meat consumption, and we can see worldwide that it's kind of increased over the last decades. And since 2015, it's kind of stabilizing, while the poultry meat consumption is the fastest, and is it's going to be higher than pig meat consumption. I think we are in the moment now, so that's the time of the shift from the pig meat consumption to poultry meat, and this is related to the advantages you can know about poultry production and religious habit and the worldwide population increasing. So yeah, we're still eating pigs a little bit lesser than in the past decades, but we're still going to eat pigs. So when we talk about meat quality, there's a lot of definition to meat quality depending on the final products. And what we know is that there is more and more transformed products which lead to different aspects of meat quality. And when we compare poultry meat to pig meat, you can see that we have different meat quality traits. For example, when we look at pork chops or sausages or ham, we don't have the same meat quality traits, and those are consumers' expectation. Here we will more focusing about drip loss, color, and tenderness of the meat, the technological ability, the processing ability of the ham. But when we look at in poultry, for example, at the carcass level will be more like the flavor or the juiciness of the carcass, which will matter for the consumer. But breast meat or thigh will be more like drip loss or colors. So we have different aspects of meat quality. So when we just say meat quality, there's a lot behind it, and it needs to be considered depending on the final product. So usually when we are talking about the quality of pork, just like we heard, people see the carcass weight, and the weight and the leanness of the carcass will determine the commercial value of the meat. But consumers also have different expectations. They are waiting for some appearance, a taste, and the tenderness of the meat. We also have for processors the processing ability of the meat, the nutritional characteristics of this meat, the sanitary effects, the aspects, the hygienic aspects, the extrinsic properties. This is the last one that is coming again and again, which more like talking about the welfare, animal welfare, and which somehow will affect the production systems of this of meat and pig. But just to give you some ideas about the parameters that we measured when we are talking about meat quality, the first one is the water holding capacity, which will be under the influence of the rate, the speed of drop of the pH, and the extent of this pH post-mortem, so after slaughter. It's only measured after slaughter. It can be 30 minutes after slaughter and goes up to 24 hours after slaughter. And the the meat is classified based on the pH. So here you got some values of what we call the normal meat, which is between 5.5 and 6.3 of pH. And when we goes below this value, we got the pale, soft, and exudative meat. And above this value, there will be the dark, firm, and dry meat. And all of that will depend also on the muscle glycogen content, that just like we heard about, and the metabolism in the muscle. But the other parameter that we can measure on meat will be the color, determined by the lightness, the saturation, and the hue angle, which will determine the purchase intent of the consumers. Based on that, consumer will say, okay, this color it's better, and I prefer to choose this one. And this is also on the influence of the water holding capacity and the chemical status of the myoglobin in the muscle. Talking about the technological ability, the processing quality, this is multifactorial. There's a lot of factors influencing these aspects. Basically, it will be the ultimate pH, the lightness, and the water holding capacity in the ham muscle. So this is a criteria used to determine how this muscle will be processed, cooked, cut, or processed to give, for example, ham to consumers. And finally, the eating and the nutritional qualities of the muscle will depend on the lipid content and the water holding capacity. This will affect the tenderness and the juiciness of the meat. Also, fatty acid composition, both and compounds, will affect the flavor of the meat. So just to sum up a little bit about all of those parameters, so we got here the criteria of selection of the meat. We have the color, the juiciness, the tenderness, and the flavor. And for example, the color will depend on the pigments in the muscle, for sure, but also the pH, which will be under the influence of the glycogen and the glycolytic potential in the muscle. The pH will also affect the juiciness, but also the tenderness of the meat. And this will depend on the contraction, the rate of contraction of the muscle fibers, but also the metabolism in the muscle fibers. The tenderness here, which I'm sure interests some of you, will also under the influence of lipids content, of collagen coming from the connective tissue, of the pH, and of the maturation. And again, the flavor will be under the influence of the maturation of the meat. So that to sum up a little bit about the criteria that we might be talking about later on in this presentation. So, having said that, we have the meat quality, and the question we can ask ourselves is what can be the leverages to improve meat quality traits. So when we're talking about meat quality, we know that it will depend on the animal and housing conditions. The genotype can influence the meat quality. The rearing conditions, the sex, and the age of the animal will also influence the meat quality. But not only, we also have feeding systems, feed composition, feed intake will be some factors influencing meat quality. And finally, we have a group of factors which will depend on the post-rearing conditions, basically the transport conditions, the slaughter conditions, and also the processing condition will affect meat quality. So
yes, and now we'll do a focus on in those conditions. Oxidative stress is highly involved. So I will come on a few slides on the basic of oxidative stress. Everything starts with the mitochondria. Mitochondria in the cell is here to produce energy, which is known as ATP, and for that it has to be fed with oxygen, which will be reduced in water. Oxygen is very reactive, and it is used by the mitochondria to produce this energy in a very efficient way. But sometimes it's not very efficient, or there are some errors or electron leaking that can be induced by different environmental conditions. And in those cases, there are electrons that escape the system, and it can be very reactive and induce damage. So, and those electron leaking or mistake that can happen will produce those so-called intermediary spaces or intermediary reactive oxygen spaces. Because as you see, normally to go from oxygen to water, you will need the transfer of 4 electrons at the end. In good conditions, physiological conditions, this transfer is done directly and there is no problem. If there are electrons escaping the systems, you will produce those superoxide, hydrogen peroxide or hydroxyl that are very reactive and can react with proteins or lipids and induce damage. So remember that in normal conditions you will directly reduce oxygen to water, but in if there are electron leakings or in animals that are growing very fast, those mitochondria are highly stimulated or produce a lot of energy, and you can have those reactive oxygen spaces that can induce damage. So we are really in the field of redox chemistry, and we must control those negative spaces. You have seen that yesterday already. As I said, in some case you can produce those reactive spaces. Maybe first of all, I have to say that we often see those reactive oxygen spaces as the bad guys of the story, and that we absolutely want to kill it. It's not completely true, because even at physiological stage, we always produce a little level of those spaces, and they are actually very useful as signaling molecules. So we need those productions, and the best example is with hydrogen peroxide, which is a very good signaling molecule that can activate different systems. But in case of challenge, environmental condition challenge, or so oxidative stress, maybe they can be produced in very high quantity, and in that case it becomes very dangerous and can affect growth and many other things. So that's why we need those other systems to regulate the productions and to control the productions. So we talk about homeostasis or equilibrium between the production and of the pro-oxidants and the reduction with antioxidants. For that, to control and to manage those reactive oxygen spaces, there are mainly 2 categories, the so-called exogenous systems that can be provided by the feed, that are most of the time essential nutrients, like vitamin A, C, E. There are other compounds like polyphenols that can also manage that. And then biologically you have also those endogenous systems. It's mainly enzymes known as catalase, superoxide dismutase, or glutathione peroxidase that can control, detoxify the reactive oxygen spaces. Here is the example that was given yesterday. So you have this hydrogen peroxide that can be highly produced in case of oxidative stress. So it's reactive, and if you don't do anything, it can react with lipids or proteins. So you would like to reduce it into a safe element, which is water. And we gave this example yesterday of the glutathione systems that use those endogenous systems with enzymes like glutathione peroxidase and some small molecules that are glutathione that can give their electrons to reduce this oxygen into water. This was during the life of the animal, but at some point we do not talk about muscle, we talk about meat, and this meat is exposed during storage to oxygen again from the environment, and those reactions can again occur. So there is still oxygen that want to be reduced into water, and it has to find electrons somewhere in the meat, and it can oxidize proteins that can influence color, but also fatty acids, and in between it can also influence the water holding capacity. So those reduction oxidation reactions also continue during storage after the life of the animal. So to summarize this, we see that during the life of the animals, those oxidative stress reactions can influence the growth by different mechanisms. It can be connected to inflammations. Inflammations is highly connected to oxidative stress. If you have a high inflammatory status, oxidative stress will also be affected. During the life of the animals, it can be exposed to pro-oxidant compounds. Mycotoxins are known to have some effects connected to oxidation. The feed of the animal can be quite rich in fat, and sometimes there are peroxide, oxidized fat, depending the quality of the fat that is fed. It's quite well known that it can have negative effect on the performance, but also on the lipid profile of the animals. And some environmental conditions like heat stress is known also to have high connections with oxidative stress. It's multifactorial thing, but during heat stress conditions, oxidative stress and those reactive oxygen species will be highly produced also. And other things like slaughter, as we said, can also influence. Then at the meat level, the meat is also exposed after to those reactive reactions. The lipids or proteins can be oxidized, which can influence the drip loss and the technological yield at the end. Then at the end, for the consumers, it can have consequence from the nutritional quality. If some of the nutrients are degraded, it can be negative. The easy example is with vitamins, but there are also you can have also some loss of functions. Some producers try to increase or enrich the meat in some specific fatty acids, long chain Boolean saturated fatty acid, but they are also very sensitive to oxidation. So it's a challenge because those meat become much more sensitive and can have a bad taste because of rancidity of those fatty acids. In those redox reactions, we already started to present that yesterday. The three main players from a biological point of view are the sulfur and sulfur amino acids with cysteines, which is, from my point of view, the main drivers. Cysteines is involved everywhere in those reactions. We give few examples yesterday, but it's really one of the main electron donors for all those reactions. The other big players is selenium. I will present again, and you will have a second chance to understand how selenium works. There are those 25 enzymes that are connected to selenium sulfur systems. So together they are able to convert and to reduce those reactive oxygen species. And finally, vitamins. So it's more connected to the exogenous systems. It's more directly chemical effect as electron donors. The best example is with vitamin E. So all those three systems are really the three main players in all those reactions. So vitamins, really quick examples. So vitamin E, as I said, has the hydroxy group that can be split into hydrogen and electrons, and these electrons will be used in those redox reactions. So it's, to summarize, it's a way to have an electron available for those redox reactions. It is very well known to stop lipid oxidations as a chain breakers, and it has also some other functions in signalings, which is still an active field of research, but less clear. And is fat soluble, so it's highly connected to lipid protection. The other vitamin is vitamin C. This one is water soluble, so it's a bit similar, but not acting at the same place in the cell. And there are also connections between vitamin E and vitamin C for regeneration. Then sulfur, so we have been presenting that yesterday. So sulfur amino acid is methionine, known for the protein synthesis, and cysteine. So in the redox field, it's more the cysteine that is a main player to all those reactions. It's the way to explain why it reacts, and it's when you look the cysteine amino acid, here presented in the glutathione molecule, which is a tripeptide, you see that the cysteine has its sulfur, let's say, at the outside of the molecule. So it's exposed to the environment, and it's how it can react easily and can give its electrons by playing with other systems, like two cysteines or other molecules. With selenium, it's very similar. When you look at selenocysteine, I will show it later. The selenium atom is also exposed, so it's a functional explanations on how it reacts from a chemical point of view. And here I give again the example with the glutathione system. So methionine is also highly known to be connected to the growth of the animal. In case of deficiency, you will reduce the growth and protein synthesis and increase proteolysis. It's also connected to the energy mechanisms of the animals. It will have less storage of lipids and muscle glycogen content. So it can influence also the meat quality of the pork. Now, methionine is the source of amino acid that can be converted into cysteine. So if you feed methionine, it can be converted through the transsulfuration pathway to cysteine, and will be used in the other system, the functional cysteine systems, like the production of glutathione. And also there are demonstrations that it influences the oxidations of protein and can be partly influence color stability and drip loss. We'll give some example later on. So selenium, so I'm using the same slide as yesterday. So as I said, selenium is also connected to those two amino acids, and thanks to the specific chemistry of selenium, it has a unique ability to attract electrons and to give electrons. And it's particularly obvious with the cysteine amino acid, that is the true functional forms. We've got those 25 selenoproteins that are enzymes able to manage and conduct those reactive oxygen reactions. So remember, for selenium, we have those two amino acids. The first one, the selenomethionine, is a storage form, so that can be released in case of proteolysis. And the second amino acid, selenocysteine, is genetically encoded and incorporated in those selenoproteins, and specifically in the catalytic site. And selenium at this place can play its role from a chemical point of view. Now I'm back on the nutrition, and I explained that to feed selenium to the animals, you have those two groups, mineral and organic forms. And now it's very well established that the mineral forms are less efficient than organic ones. And the main explanation is the purity as selenomethionine, because selenomethionine is really the true source and the true way to supplement selenium. I didn't tell it yesterday, but it's like if when we talk about methionine, we never say we need some sulfur. We say we need some methionine. So when you buy a bag of methionine, you do not buy sulfur. You buy the molecule, like any other product. And the crosstalk, so we have been demonstrating that there are nice connections between selenocysteine systems and sulfur systems like methionine and cysteine. And with those examples of the glutathione system and the fixing of methionine sulfoxide thanks to this reductase, which is a selenoprotein. Now we'll come back on the different solutions and leverage that could improve or maintain good meat quality. And the main focus will be on the feeding strategies. That is very interesting for Adiseo. And we'll see if those different level and dosage of methionine and selenium can influence some meat quality parameters.
How can we manage the feeding system, the feeding composition, and how it can affect pork quality? So here is an example, the two examples actually. The first one is the study that we conducted at INRA of Saint-Gilles, and we supplemented finishing pigs during 14 days before slaughter, with an increase of methionine. In the first trial, the source of methionine was hydroxymethionine. So this was a control treatment which was adequate in all amino acids and all nutrients. And in the blue bar, we increased methionine, only methionine, 3 times above sulfur amino acid recommendation. And in the pink bar, it was 5 times above sulfur amino acid recommendation during 14 days. So we measured drip loss during the first 4 days and during the first seven days, and you can see that with this treatment, with an increase of methionine, we tended to decrease the drip losses at the 2 time points of measurement. And this is another trial that we performed with a lesser increase of methionine, and here we compare the two methionine sources. We only have 25% increase of sulfur amino acid through either DL-methionine or hydroxymethionine. And the difference here is that we started increasing the level of sulfur amino acid since weaning until the end of the growing finishing period. So 25% increase, but all along the growing finishing phase. And you can see that we got the same result of the decrease of the drip loss with an increase of methionine. And this is really connected to the glycolytic potential, which tended to be decreased with the increase of methionine, and also affect the pH. We'll see in the 2 slides. And this it's quite the result observed on glycolytic potential is opposite, because in the past we did a trial with a deficiency in methionine, and we observed that the glycolytic potential is increased. So here with an excess, a little bit excess of methionine, we got the opposite result, and an improvement of drip loss with the increase of methionine.
Yes, with selenium there are also some results in the literatures that shows that it can influence the drip loss. So here in those graphs in pork meat, there was a comparison between selenite supplementations at different level and seleno yeast supplementations. And so you have increasing selenium content in the diet and the level of DRI+. So the first thing that was seen is that actually the selenite source can have a negative effect on the DRI+. It can increase it. It's quite well known that selenite has some extra reduction steps and which induce higher toxicity of this product at some levels. The organic forms of selenium, like seleno yeast, do not have those extra reduction steps. So that's why also they are said to be less reactive, more safe, and it could be connected here with this higher redox systems that could degrade. So most of the time, selenite has more negative effect than not selenium at all. So here with the organic forms, there was tendency to reduce it or to maintain the DRI+ at the same level, but it's more the selenite that has a negative effect. So organic forms could tend to reduce it or maintain the DRI+, and selenite have more negative effects on that. More recently, we did some field trials where we wanted to test the effect of our organic form of selenium, and there was different groups that were tested. So here in that study, conducted in Spain, there was a control group fed a standard diet, supplemented with selenite at 0.1 milligram per kilo of feed, and the test group was this control feed with on top of it the hydroxyselenium methionine at 0.2 milligram per kilo of feed. So there was 12 pen replicates times 11 animals, and during the last 59 days before slaughtering, they were fed those diets. And here I zoom on some specific results, but one of the most interesting one was observed on the female populations, where we observe reductions of the DRI+ between those two groups. So first, it has to be said the percentage of DRI+ is quite low. We are about 3% of DRI+, but still it has been reduced by something like 0.4%. It represents a drop of 11%, but unfortunately this was not significant. It's also because of the statistical power of the analysis, so it's a bit disappointing, but it sounds to be important and quite should be tested on maybe larger scales, even if it was already big. On the pH, there was a slight reductions of the pH, which also was not significant, but it also affects the pH. So maybe the message here is that there are many studies looking on those DRI+, and it's very complex to measure and to have consistent results. And focusing on experimental units with small number of animals is not easy. Maybe we should go on much larger numbers also. So remember that there is a tendency to reduce DRI+ also with the hydroxy selenium source, which is something known in the literature. Other facts are connections to selenium and vitamins to lipid oxidations. It's very well known. There are more descriptions in the poultry topic that oxidized fat can have negative effect on growth performance. So it can be because of the oil has been transported at very high temperature, and the peroxide value is highly increased, and the feed producers have to use that oil anyway because it's they bought it, and it can have a negative effect on the animal growth performance. The other topic is about the Boolean Saturated Fat. As I said, some people try to enrich in the meat in those long-chain fatty acid. There are some health claims to equilibrate the human diet in those Boolean saturated fatty acid. Unfortunately, if you enrich the meat in those specific fats, it's become much more sensitive. And it can have bad taste, bad flavor, and induce rancidity. And there are very nice demonstrations that selenium and vitamin sources at different levels could limit either the negative effects of oxidized fat or prevent the oxidations of those polyunsaturated fatty acids. Most of those data are from poultry research, and we think that we can have a similar hypothesis in the pig industry for pork meat, but this still has to be investigated.
So another criteria that we were talking about was the pH, and here is the ultimate pH in the first study, where we increase 3 times and 5 times the methionine level in the diet, and you can see that in different parts of meat, of muscles, we significantly increase the pH here in comparison to these two treatments. In every segment, we measure the pH. So we were able to influence and to increase the pH. And when we look at the classification of the different meats that I presented in my first slides, so here was the level of the PSC meat, so the meat with acid pH, and you can see that even if we have a tendency, we tend to decrease this the rate of this meat with the increase of methionine. And in addition to that, we calculated the meat quality index, which is, if you remember, based on the ultimate pH, the lightness and the water holding capacity of the ham muscle. And you can see here that we tended to increase it with we significantly increase it with increase of methionine. And in the last presentation, you saw that an increase of 0.1 of ultimate pH can result in 1 point improvement of processing yield. And this was interesting result from the ladies from INRA, they were really excited about this result because it was the first time they were saying that through feeding we can have this result on meat quality index. In addition, we also look at the meat tenderness in the second study with a 25% increase of methionine during the entire growing finishing period. And we can also see that we tended to decrease the shear force. So the lower the better. The lower shear force we have, the better tenderness we have. And we tended to decrease the shear force with the increase of methionine. And there's numerical difference between HMTBA and DL methionine on this aspect. So a slight increase of methionine can also result through its cascade of glutathione systems and the observation that we made on energy metabolism in other studies can influence some relevant criteria in meat quality and pork specifically.
And finally, I dare to present some results on turkey, because when you look in poultry, it's more white meat compared to beef and pig, which is more a red meat. And it's known that those red meat are much more sensitive to those redox or oxidation problems. Turkey is a bit in between. It's a bird, but the definition of the meat or the fibers is more red, and that meat is more sensitive to oxidation. So from my point of view, it can be quite a good model to study meat quality, because it's maybe easier to implement compared to pig or beef study, and you can have nice trials. So those results are connected to a study how the meat discoloration is occurring. It's very well known that the thigh or the leg meat of the turkey is highly sensitive to discolorations. So here, so do not look at the green things here. It's some cucumbers, I think. It's the green in the meat that is interesting. So it's the brochette we use for barbecue for the summer. So they are already in the packaging. And those thigh meat are very well known to become green or brown after a few days. So theoretically, you can sell that meat up to 15 days. From a sanitary point of view, it's not a problem. There is no bacterial development. But unfortunately, after 5-6 days, the color starts to become brown and green. And consumers, and I'm the first one, I will not buy such meat. So this problem is very well known, and we wanted to investigate if some nutritional solutions, and selenium of course, could slow down the occurrence of this problem. So yes, the color is mainly due to the oxygen and light connected to a pH, as we said, microbiology, but we know this was not the problem, and myoglobin and myoglobin oxidations that makes this color modification. And I will jump directly to the results. So we did a study with turkeys that were fed during the last 2 weeks before slaughtering different selenium levels and sources. So there was a first group fed selenite and a second group fed siliceo, so the organic forms. So we know that the transfer in the muscles is highly improved with the organic forms. And in the muscle, we have been measuring the glutathione peroxidase activity. And results have been showing that this activity was increased. So it's thanks to this higher bioavailability of the organic form that can influence this selenoprotein enzymes and activate it in a better way. This enzymes is here to prevent oxidations, and it can be lipid oxidations. And one way to assess the lipid oxidations in the muscles is measurements of the malondialdehyde, which is one of the lipid peroxide. Similarly, it has been measured in those muscles, and we have been observed that the level of those lipid peroxide was lower. So we can hypothesize that it's thanks to this higher level of selenium and glutathione peroxidase that prevent the lipid oxidations. And now when you look on the scoring, so this was the visual scoring of the meat that was done by a panel of people that assess the occurrence of green and brown meat. There was a ranking from good color, so more red, to a bad color, up to 4, on different days. And the results show that we were able to reduce or to maintain, let's say, the good color for a longer time. At the end, the green-brown problem occurs. We cannot stop it completely. You see that after 13 days, almost all the meat has a very bad score, but still the score is better with when the animals were fed the organic forms. And at the end, we conclude that you can slow down this problem of color by 1.5 days. The other way to say it is that people should be able to accept and to buy that meat in 1.5 days more. So you have the chance to sell the product for a longer period. So this was a very nice demonstration. 3 trials have been done actually, and each time there was a consistent result. So we have been demonstrating that those redox mechanisms can highly influence color not only drip loss. Me or you?
I don't mind. So just to give you some take-home messages to sum up all of this information. So we saw that meat quality is defined differently according to the final objective and where we stand. And meat quality is also influenced by different factors, including feed composition and feed intake. And we show you some literature data and showing that all along the value chain, we can have oxidative stresses. And one of the two major players the redox homeostasis are sulfur amino acids, selenium, selenoprotein, and the third one is vitamins. And by managing, by changing a little bit our habits on those specific nutrients, we can succeed to reduce drip loss, to improve the technological quality, the processing quality, ability of the meat, and also improve meat tenderness. So those are some approaches talking about feeding that can help you guys influence meat quality. And now we are here to listen and hear your question. Thank you.
Thank you.
Thank you very much for your presentations. And we have a list of questions. And the first one is, do the extra money earned through the reduced drip loss reimburse the extra feed cost due to methionine supplementation?
Yeah, that's a good question. For now, I'm sure the people from IFIP can confirm or deny it. I'm not sure that they are buying meat based on the drip loss, and in France, for example, the system is not integrated, allowing to pay the producer the money they will involve in feeding, and allowing them to value it on the processing side. You can confirm it. Yeah. So there is one investing money to improve the meat quality, but it's the slaughterhouse that is benefiting from it. So there's a huge gap in order to take this into account and allow people to be paid for the money they are investing. But I guess in some countries like in Spain, for example, probably, I don't know, maybe it can work.
Thank you. And the next question is, how can we explain that you reduced both the pH and drip loss with organic selenium? Most time reduction of pH is related to the drip loss.
Yes, the explanation today is not very clear. Probably the main hypothesis is more on the structure of the muscles. If you prevent some protein oxidations and lipid oxidations, you would maintain a better cellular integrity and thus a better water holding capacity. So indeed, there was those slight pH reduction, so should be bad news because it should degrade the drip loss. But it's maybe through another mechanisms, more through optimal cellular integrity that would conserve the water, because you protect proteins structures, lipid structures, and release less water actually. And pH is more connected to glycogens or other mechanisms.
Thank you. And the next question is that pen mates are often slaughtered over different weeks. So would it be a problem for the last ones to receive extra methionine over an extended period?
If they receive methionine for a longer period, yes. It depends on the dose, actually. In the second trial that I presented, there was 4 months supplementation of 25% more methionine. So there was any problem about growth performance and feed intake, so no problem about it. But in the first trial, we have 3 times to 5 times more methionine supplementation for only a shorter period. So if we are talking about, basically in the trial was 5 kilo per ton of feed and 10 kilo per ton of feed. And I'm not sure we can go longer than a certain time, because methionine is given homocysteine, which is kind of toxic for animals, and we cannot do it for example, 4 months of supplementation of this dose.
Thank you. And there's a question out, well, a difference in feed intake with the high level 3 times with the requirement of HMGPA in the study of Briens?
Okay, no, there was no difference in feed intake and growth performance. There was similar feed intake, similar growth performance for all animals in the three treatments group that received the control or the 3 times and 5 times more methionine. So no negative effect of this dose on this shorter period of supplementation.
Okay, thank you. And there's a question on why is drip loss in trial 1 around 6% and in trial 2 around 2%. I don't remember which. I think it was your trials.
Yeah, I think when you look at drip loss, it's generate data. You have some studies. It's about 5-6%, sometimes 2%. It depends the regions. It depends the growing systems.
The genotype. So.
Genotypes, there are many factors. So when you are at about 2-3%, you think there are few rooms to improve it. In some systems, some regions, there are 5-6, sometimes more. So you could guess there are more room to improve it, but it's not always true, because one of the nice results we had was with a drip loss already low. So I think it's interesting to see where you are, but I think in both cases you have some room to improve it.
Thank you. And the last question from the slide is how did you calculate the meat quality index?
Okay, so there's an official calculation based on the ultimate pH. There are some correlation factors. So most of the variables used are pH, ultimate pH, the lightness of the arm muscle, and the water holding capacity. Those are the main 3 factors used, and you have different parameters that varies with each variable. So the equation is available. It's been used for a while now in France, so you can find it easily, or I can share this with you.
Okay. And what would be your recommendation for methionine and level and source for the grower finisher pigs in relation to meat quality?
Yeah, that's a nice question. What will be the recommended level? We saw that at two different levels we got good performance. It will be decided based on the money that farmers will invest, and what are they willing to invest, and what is it paid at the end of the day. So it's kind of balanced. I can give you a straight answer about it, because I'm not a producer, and I can give some insight, but it will be only from R&D point of view, and when you are on the field, it's kind of different, and we need to discuss with every single country and every customers to say, okay, this is the result, this is the fact, and how can we manage together to find a solution about it. And probably in some country there's still some things to do to value those aspects to producers, and maybe come to more like I don't know if it's the integrated system which will work better, but there's, like I said before, there's one investing the money, another taking the money back, so it's kind of hard in France, for example, to discuss about it, but it's still nice result, and maybe we are preparing the future. Maybe in the future the habit will change. I hope so, and I guess it can help.